we are looking at stationary points. When you talk about stationary points, let's say you've been given an equation. You've been given an equation. Okay, something like this. This is the equation that you are given. So if you see at this point, the equation is turning. Even here, the equation is turning. So it has 2 points where it is turning. And at these 2 points, these we call them turning points. The other term we use is a stationary point. We are saying stationary because it is no longer moving, it is having a change in direction. So those are stationary points. And they are very important for us to understand. Specifically, of course, this is calculus that we are looking at. Okay. So one thing that we can notice, let's say if you've been given a graph that is on a diagram like this, let's say like something, let me put it here, okay, like that. If you want to find the stationary point is somewhere where the graph is changing, where the graph is turning. And every time, so the turning can either be up like this or it can be down. Okay. So at this point where there is turning, the gradient of the line is equal to 0. This is what I want you to take. This is very, very important. The gradient of the line is equal to 0 at the turning point. Please take this in mind. The gradient is equal to 0 at the turning point. So everything that we are going to be working out, we are using that same principle to say at the turning point, the gradient of a line is equal to 0. Let's say we have been given a curve y is equal to, let's say, 3x squared minus 12x. Okay, the question is find the coordinates of the turning point or the stationary point of this curve. Find the coordinates of the stationary point. Now this question, you mostly see it in paper 2 of mathematics. Okay. It's a bit of slow when I write. You might not see there and then because of just internet things. So I'll just wait a bit so that what I've written starts showing. Alright, so here is the question. Find the coordinates. Now the way that I've written these coordinates. Okay. Find the coordinates of stationary points of this curve which we have here. Now what you do is you need to find the gradient of this curve. Remember we said at the stationary points the gradient of the curve is equal to 0. So we need to find the gradient. And for you to find the gradient of a line, what you just do is differentiate the equation. What you are going to have will be called a gradient function. So we are going to say dy over dx. Okay, we are differentiating. That is going to be equal to, we'll get the power 2, we multiply with this number that is in front, which is a 3. So that is going to give us a 6. Alright, and then we're going to write x. Now this power 2, we are going to remove a 1. It is 2 minus 1, meaning that the power will now be 1. Okay, for this x, even if we can't see there is a 1 as a power. So we'll get this one, we multiply by the negative 12. That will be negative 12. And then we write x. Now this same power 1 which we can see, we remove a 1. 1 minus 1, that will be 0. So we are seeing that dy over dx is going to give us 6x. Power 1 can just, even when you don't write 1, it doesn't make any difference. Now you know that from the laws of indices, any number raised to the power 0, the answer is 1. So x to the power 0 is 1. And then 1 times negative 12 will just be negative 12. Okay. Are we okay up to this point? Please, if there is any question that you have, just open the microphone and be able to speak. Are we okay up to this point? Are we good so far? Okay. Now, all right. Since we want to find the coordinates of the stationary point, this thing we are seeing here as dy over dx, this is what we call the gradient of a line. And at stationary points, dy over dx is equal to 0. Okay, this is what we need to know. At stationary points, dy over dx is equal to 0. Alright, so meaning that where there is dy over dx, I'm going to put 0. So this is going to be 0 is equal to 6x minus 12. I'm going to take the minus 12 the other side, so it becomes positive 12 is equal to 6x. So to remain with x, I'm going to divide both sides by 6. So we are going to find that x is equal to 2. So this is the x value of the stationary point. Now the question is saying coordinates. So coordinate is x value and y value. So to find the y value, we're going to come in this equation which is here. So we're going to say y is equal to 3, but where there is x, I'm going to get 2. And then squared minus 12. Where there is x, I'm going to put 2 again. So all I'm doing is I'm putting in this equation. Okay, that's the one we are putting in. So this is going to give us y is equal to 3. 2 squared is 4. Minus 12 times 2 is 24. So this will give us y being equal to 3 times 4. That is a 12 minus 24. 12 minus 24, this will give us negative 12. So we are saying now we need to write the answer because they've said coordinate. So therefore the coordinate of the stationary point, x value is 2, the y value is negative 12. So this is the coordinate. You always start by the x value and then you write the y value. So at the turning point of this graph, you are going to have 2 comma negative 12. Are we okay? Are we good? Okay. All right. Now, we can also determine if our equation is going to be a minimum or a maximum, or if the turning point or the stationary point is going to be a minimum or a maximum. Let's say we've been given the equation y is equal to, we can say 3x, let me say 2x to the power 3 minus, we can say x to the power 2. Okay, we can also say minus, what can I put here? Okay, minus 2x and then plus 4. So this is the question that we have. Now the question is, let me just check out something before I even start. Okay. Okay, let me put a 2 there. Let's hope it will make sense. So the question is, determine or find the coordinates. Let me just say determine the maximum and the minimum of this equation. Now, when we say maximum, if you have got a graph which goes like this one, this is called the maximum. And then this one where it is turning downward, this is called the minimum. So this is what we want to find. We want to determine what would be the maximum point and what would be the minimum point. Now, the first thing that you need to do is you need to find the stationary points, or you need to find the points where the curve is going to turn. We also refer to them as the turning points. And how do you do that? You need to find the gradient. So you say dy over dx is going to be equal to, you get this 3 the power, you multiply by the 2. 3 times 2, that would be 6, and then you have got x. So the 3, remove the 1, it becomes 2. Alright? Then minus this 2, multiply with this 2, that gives you a 4. Alright? And then this x, the power, it was power 2, remove the 1, it becomes power 1. Now writing power 1 is the same as writing just x, right? And then this is a negative 2x. Now when you just have a number with x, when you differentiate, the letter is going to go. So just remember with a negative 2, right? And when you differentiate a number that doesn't have any x, that is a constant, you always get 0. So that is 0. Okay, so this one, if you differentiate, you get 0. So this is the answer that we are going to have. Before I proceed, are we okay? Are we okay so far? Yes. Which one? If you differentiate 4, you are going to get 0. We are differentiating dy over dx. If you differentiate a constant, you get 0. So that's why you're not sure. I would have said plus 0. Okay? Alright. So from this point now, remember we are first finding the turning points before we can determine the maximum or the minimum. So where there is dy over dx, we are going to put 0 now. This is going to be 0 is equal to 6x squared minus 4x minus 2. Now since we can see 2 can go in everything, I'm going to divide everything by 2. 0 over 2 is still 0. 6 over 2 is a 3. 4 over 2 is 2. 2 over 2 is 1. So if I want, I can take this is equal to 0 this side. So what we are going to have is 3x squared minus 2x minus 1 is equal to 0. Now this is a quadratic, right? So this number in front of x squared is called a. The number in front of x is called b. The number in front of 1 is called c. So we need to factorize out this quadratic. We need to factorize it. And how do you factorize out? You need to find the product. Now the product, you multiply a and c. So you multiply 3 and negative 1. That is going to give us negative 3. And then the sum, you get b. And b here is negative 2. So that's the one you get. So we are looking for two numbers. If you multiply, they give you negative 3. If you add, you get negative 2. Do you know any two numbers? If you multiply them, you get negative 3. If you add them, you get negative 2. Any two numbers? two numbers that you can multiply, you get negative 3. If you add them, you get negative 2. Two numbers. Okay. So it is going to be positive 1 and negative 2. I mean, it should be, since you want, when you multiply, okay, it should be negative 3 and positive 1. 1 times negative 3 will get negative 3. 1 minus 3, you are going to get negative 2. Okay, so those are the two numbers. So I'm going to rewrite this one, which is on the middle. So we are going to have 3x squared. Where there is negative 2x, I'm going to put these two numbers. We have first a positive 1. Now we're going to put an x, so it becomes positive 1x. And then I've got a negative 3, so that would be negative 3. I'll put an x. And then I'll write this one, which is at the end, which is a negative 1. That is going to be equal to 0. So I'm going to get this first 2 and then this last 2. We factorize them. So from the first 2, x is common. And then 3x is going to remain plus 1. And then on the last 2, I'm going to remove a negative 1 since it's common. Remove a negative 1. If I remove a negative 1, here what remains is positive 3x. Here what will remain is a positive 1. And this is going to be equal to 0. So since we can see that this is the same as this, I'm going to get this and this, I pair them, or I put them together. So this is going to be x minus 1, 3x plus 1 is equal to 0. And then equate this to 0, also equate this to 0. So let me remove this. Yes?
Can you pop out my list? How to find 6x power 2?
You multiply this 3 and 2.
This, that you are saying that you have to take 2 times 2 times 2 is 6, right? So how come his power 2 is equal to?
No, if you multiply 3 times 2, that will give you 6. And then you remove a 1 from 3. That gives you 2. Okay? Alright. So at this point where I've reached, we are going to equate both to 0. So we are going to say x minus 1 is equal to 0, or 3x plus 1 is equal to 0. So this will give us x minus 1 is equal to 0, or 3x is equal to, I'll take this one the other side, it becomes negative 1. And then take 1 the other side, so x is going to be equal to 1. Or divide both sides by 3, x is going to be equal to negative 1 over 3. So this is it. Now, if we want to determine which one is going to be the maximum and which one is going to be a minimum, there are two methods that we use. So this is the x value of the turning point, even this one is the x value of the turning point. Now this question, they like bringing it in paper 2. So if they said find the coordinates of the turning point, if you find that x is equal to 1, so go in this equation, you also find the y value. Okay, so you say when x is equal to 1, all right, when x is equal to 1, y is going to be equal to, you come where there is x, you substitute 1, you find the y value. And then you are going to also say when x is equal to negative 1 over 3, y is going to be, you come in this one, you substitute where there is x, you put negative 1 over 3, you find the y value. If they said find the coordinates, please, this is very, very important. I hope we have gotten that. It's very, very important. Okay, so what I'm going to do is this one which we have here, to determine which one is a maximum and which one is a minimum, I'm going to differentiate it again. Now this is already dy over dx. If you differentiate it, it gives you what we call d2y over dx2. This is called the second derivative. So in other words, differentiate this again, all right? So 2 times 6, that is going to give us a 12. And then instead of being power 2, that will just be x to the power 1. And then differentiate 4x. Remember we said if you differentiate something that has just x, the x will go. So it just be a 4. Now this is a constant. Remember we said when you differentiate a constant, you are going to get 0. Okay, this is the second derivative. Now what you are going to be doing is you are going to be getting these values of x you put in there. So we are going to say when x is equal to 1, so when x is equal to 1, and then you are going to say d2y over dx2 is going to be equal to 12. We are putting in this one, where there is x, we put a 1 minus 4. The answer is going to give us 12 minus 4, which is 8. All right, and then you are going to say when x is equal to negative 1 over 3, you say also d2y over dx2 is going to be 12 multiplied by, where there is x, you put negative 1 over 3 and then minus 4. 12 multiplied by negative 1 over 3 is going to be negative 4. Negative 4 minus 4, that will give you negative 8. So when you find this value as positive, this is a minimum. When you find this value as negative, this is a maximum. So this is how you determine the minimum and the maximum point, or the minimum and the maximum stationary or turning point.